Physical Science 2015, question 13. 10,000 kilogram truck is moving downhill when its brakes fail. The runaway truck can use a safety ramp that allows it to travel uphill to slow down. The ramp is inclined at an angle of 15 degrees as shown in the diagram, and the truck enters the safety ramp at 45 meters per second. That's pretty quick. Show that the kinetic energy of the truck as it enters the safety ramp is approximately 10 megajoules. Remember, megajoules. If we go back to the inside of the front cover, you've got M for megajoules, means 10 to the 6 joules. Okay. How do we find out what the kinetic energy is? Kinetic energy is equal to a half mv squared. So EK equals a half mv squared, which equals a half times the mass of the truck, which is 10,000, multiplied by the velocity, 45.0 squared. Don't forget to square it. Happens a lot. Let's cancel out of that. What we have here is 0.5 multiplied by 10,000 times 45 squared equals, wow, look at that number, equals 1, 2, 3, 4, 5, 6 equals 10, 1, 2, 4, 0, 0, 0 joules, or 10.125 megajoules. There you go. So we've got that out of the way. Safety ramp allows the truck's kinetic energy to be converted into potential energy, gravitational potential energy. What is the required minimum height to bring the truck to rest? Okay, well, what's going to happen here is the truck is going to come down here. It's going to hit with 10.125 megajoules of energy. Now that energy is going to be converted to gravitational potential energy, so that the higher it goes, the more gravitational potential energy. So if we're assuming it's all going to be converted to gravitational potential energy. So EP at the top will be equal to mgh, so that which will equal 110.125.000. Now, therefore, mgh, well, the mass is going to be 10,000 multiplied by 9.81 multiplied by the height is equal to 10.125.000, or 10,125,000. So if we divide all this through by that, if we divide that by these, divided by 10,000, and then divide that by 9.81 equals 103.2 meters. Therefore, H equals 103.2 meters. Well, just over 103 meters. That seems pretty tall to me, but anyway. Calculate the minimum length L of the safety ramp required to bring the truck to. So basically what we have here, and I'll just draw it down here a little bit, is a little bit of trig. 15 degrees, 103.2, and what is, we'll call that the L, because that's what it's called. That's going to be a right angle, and there's a little bit of trigonometry. Remember, if all else fails, you've got your trigonometry in here. If that's the angle there, it's going up that way, and that's your height. Well, we've got an opposite, and we've got the hypotenuse that we're looking at. So opposite over hypotenuse, you're using sine. So sine of 15 degrees is equal to 103.2 divided by capital L. Now we need to rearrange that. So we get L by itself. So that will multiply through by that, and then divide through that by sine 15. So we get L is equal to 103.2 divided by sine of 15 degrees. I'll bring that back to my calculator. 103.2, I guess it was already up there, divided by sine Make sure that's on degrees. Yep. Check that before you start the exam. 15. 398. So we say 399 metres. L equals 399 metres. (2015) final year exam for physical science, and this is question 13 part, or the second part of that, because I forgot to complete it. Anyway, we'll see how we go. So we've looked at here and we've seen the truck going down the ramp, and we've worked out the first three sections. But if we turn over the page, we can see here that there are some more bits to answer. So the truck came to rest 100 metres along the safety ramp with a potential energy gain of 2.54 by 10 to the 6th joules. Calculate the frictional force against the truck whilst it was on the safety ramp. Okay, so what you need to do is let us work out calculate the frictional force. So if we're going to work out the force, if we know the total work done and divide that by the displacement, that'll give you the force. Now, in order to find out the total work done, we need to find out how much energy was lost to friction, and that will give us an idea of how much energy. So we can do that. So let us do that first of all. So the work done equals the change in energy, which is going to be equal to, let me have a look here. So we're going to have this value here, which equals 10,125,000, which is the total energy of the truck. And how much of it is lost is going to be, well, how much was 2.54 by 10 to the 6? That's how much was transferred. So of the available energy of the truck, from all the kinetic energy, this is all that was converted into potential energy, gravitational potential energy. So the rest of it has been converted into, has been used up as heat and sound as friction. So let us go 10,125,000 minus 2.54 x to the 6. So we've got here, we've got 7.585 multiplied by 1, 2, 3, 4, 5, 6 by 10 to the 6. Can you see that? Or is it that? If I move it up there, that's probably better. By 10 to the 6 joules. Okay. Calculate the frictional force. Is that the end of the story? No, it's not the end of the story. Because what we need to do is to, and as the work done, so work done is equal to force times S. Therefore, the force is equal to the work on S, which equals 7.585 by 10 to the 6 divided by the total displacement, and that is, it's gone 100 metres along this. So let us divide that by 100. 75,850 joules, or 75.9 kilojoules. Oh, look what I've done there. They're not joules at all. It's going to be newtons, because it's a force, isn't it? Force is equal to newtons. And what's more, it's going to be down ramp. Down ramp. Would the minimum length of the escape ramp need to be different for trucks of greater mass? Okay, no, it would not. And the reason it would not, no, is because, I can probably best explain that. As the truck comes down, if a truck comes down here, it enters at 45 kilometers per hour, then the amount of kinetic energy it has depends on the mass. But as it's converted back up to here, then the gravitational potential energy also depends on the mass. So that would be the heavier the object is, the greater the potential energy, but the more that the greater the kinetic energy, but the more that the potential energy it has. So what happens here is that at that point, what we have is the minimum length is independent of the mass of the truck. So basically, if you had a half mv squared as the kinetic energy, that's going to be converted into mgh. So what happens is that the masses will cancel out, and so it's actually independent of that.